All right, we're going to look at 6.3 and 6.5 together. The reason is 6.5 has some interesting stuff about transformations of the plane to itself, which is useful for computer graphics type stuff. And 6.3 is a little more theoretical stuff, and rather than doing all the theoretical and then the computer graphics stuff, I want to mix them in together. So first up, let's look at this. Given a formula, find the matrix for it. So suppose we're given this linear transformation, t of xy equals 2y, x plus y, 3x minus 4y. So I'd like to rewrite this so that we have t of x is equal to some matrix times xy. And so finding this matrix is the thing that we're, sort of the goal here. So first up, let's look at what this is doing. This is taking in an ordered pair and spitting out an ordered triple. So T is going to map R2 to R3. So what we've got is a matrix here, and it's multiplied by xy, and that's going to give us 2y, x plus y, 3x minus 4y. Okay, so this is 2 rows by 1 column, this is 3 rows by 1 column, and so to make the matrix multiplication work out, this over here has to be a 3 by 2. That way these match up, and these give us the 3 by 1 over there. And it's actually really easy to come up with what goes over here. This is 3 rows and 2 columns. So the first column is just going to be, what do we have to multiply this by to get this? Well, that's this over here consists of just 2y and no zeros. So this is going to be 0x plus 2y. Similarly, x plus y is going to give us 1, 1. And 3x minus 4y gives you 3 minus 4. So it said let's rewrite it using a matrix. So I guess what we should do for our final answer would be rewrite it as t of xy is equal to 0, 2, 1, 1, 3, negative 4 times xy. And that's it. Now, this matrix is called the standard matrix of the linear transformation. And it's called that because we're using the coordinates here. They're all with respect to the standard basis. You can represent the same linear transformation with respect to a different basis, and that would have a different matrix. But really, all we're going to look at here is just the standard matrix for these things. So let's do a few examples. Find the domain, codomain, and standard matrix for this linear transformation. Okay, so if you look at this, the domain, this maps something with 2 elements, so its domain is R2, and this has 2 elements in it, so it maps R2 to R2. So that's our domain and codomain, they're both R2. And I'll write this out even though it's probably not really necessary. Well, actually, it probably is necessary to do this at least the first couple of times. So 3x plus 4 and then minus 2x. So the standard matrix is going to be, let me make it a little bigger. The standard matrix is going to be a 2 by 2 matrix. And it's just the coefficients from over here. So the top row is going to be 3, 4. And the bottom row is going to be minus 2, 0. And this problem just said to find the standard matrix, so I'm going to circle that or square it, and that's our answer. Okay, example 102 is the same thing. In this case, we've got 4 things in our input, and over here we've got 2 things in our output. So in this case, T maps R4 to R2. And so our standard matrix, let's see, it's going to look like this. This gives us x1 plus x2 x3 plus x4. So we could go through here and see this is going to have 4 elements across here so that we can take the dot product of that and that. And we're going to have 2 rows. So this is going to be 2 rows by 4 columns. And the entries for this top line are going to be 1, 1, 0, 0. And for the bottom line, it's going to be 0, 0, 1, 1. All right. So that's how you find the standard matrix.